Earlier this year, the U.S. banned microparticle beads from personal care products, but Europe has still yet to follow suit. Now, researchers at Uppsala University are increasing the urgency, as for the first time, they have been able to show that fish actually prefer to eat microplastic beads rather than their own food of zooplankton. This is causing disastrous effects on their survival. I'm Fanny Yoon, and I spoke with Dr. Anna Lonstead to better understand the issue.
I looked at how microplastic pollutants affects fish communities. I used naturally occurring levels of microplastics and exposed fish during their development to look at how hatching rates, behavior, and activity rates were affected. Now, what we found was quite scary because their hatching rates were much lower, they had altered behaviors, and then we found that they did not respond to predators, and as a consequence of this, they were eaten much quicker than control fish that had not been exposed to microplastics. One of the more interesting and surprising results from the study was that the fish preferentially ate microplastics over their natural food source of zooplankton.
So why do these larvae choose to eat microbeads rather than their food?
We believe it's either a chemical or a visual cue in the microplastics that trigger a feeding response in the fish. So when they see the microbead, they think it's a really high energy resource that they have to ingest in large amounts.
And why do they ignore the smell of predators?
Well, that could be for two reasons. Either it's because the microbeads contain some sort of toxic chemical that has affected the nervous system of fish, changing their behaviors. Or it's because they've only been eating microplastics. So their stomachs is only full of plastic and they have no energy to respond to predators.
Do the fish preferentially eat microbeads only if microbeads were present during their hatching? Or do you get similar characteristics if you add the microbeads to properly hatched larvae?
We tested both ways. So first we had microplastics during hatching, and they ate the plastics. And then we had no microplastics there during hatching, and we tested them again, and they still ate the plastics. So this seems to be a very universal response, regardless of what their hatching environment has been like.
Have you been only exploring larvae, or have you seen if older fish also do the same?
Well, we've looked at juveniles, and they also do the same, but they tend to select larger microplastic particles.
And so what do you think we should be doing about this situation?
Well, I think it's really important that other countries follow suit, and they also start banning microbeads in their personal care products. I also think it's very important that we start looking at alternative options for plastics, so biodegradable products. What we are trying to do now is find the chemical that makes the fish behave so odd. If we can pinpoint or target the chemical composition of the polymer, then we can actually start phasing this out of microplastic production.